So, welcome to the online conference today, facilitated by the Society for Underwater Technology, the SUT, in partnership with the International Umbilical Manufacturers Federation, the UMF. Today we have speakers from the UMF who will be focusing primarily on developments in umbilical technology for shallow water applications. There's a growing interest and size of opportunity for long and short umbilicals in the Middle East, and this event is designed to give some invaluable insights from the leading manufacturers of umbilicals. My name is Neil Brown and I'll be your moderator today, and I work for Energy Business Catalyst, who provide strategic and management support to the UMF. I would also like to thank Adrian and the SUT for hosting this event. Adrian incidentally also conducts work for EBC as well as for the SUT. Just a short word about the Umbilical Manufacturers Federation before I introduce the first speaker. The UMF was founded in 2001 with the objective of promoting the benefits of umbilical products for the offshore oil and gas industry. The organisation seeks to build and improve upon the established high levels of quality, reliability and safety of umbilical products. This is achieved via engagement with material suppliers, international specification bodies, system designers, installers, operators and other interested parties. The joint interests of the member companies are the maintenance and reputation of umbilical products, and to ensure such products are manufactured in a safe and environmentally friendly manner. And it also seeks to provide system designers and engineers and end users with guidance notes for the use of umbilicals. The UMF is proactive in engagement with the industry by means of workshops and joint industry projects, and engage through our Secretariat, Technical and Health and Safety Committees. We have different levels of membership, including for associate members and operator members, and would encourage those wishing to apply for membership to contact us directly or through the website. Before I introduce the speakers, I'd like to invite you to offer and post your questions within the Q&A tab, which we will do our best to answer after all of the presentations. So without further ado, I'd like to introduce our first speaker. This is Joe King from Aker Solutions. Joe currently resides in Alabama. He earned his bachelor's degree in mechanical engineering from the University of South Alabama and started his professional career at Aker. He became lead engineer for several umbilical projects that were delivered to different parts of the globe, including the Gulf of Mexico, South China Sea and Persian Gulf. And Joe now works as the umbilical product manager for the North America region. Over to you, Joe.
Thanks, Neil. Hello, everyone. My presentation today will be on long step-out umbilicals in shallow waters. Just give me 1 second. I'll share my screen. All right, are we good, Neil? Can we see?
Yes, we can see.
All right. Okay, long step-out umbilicals in shallow waters. So I've broken this presentation up into basically two sections. The first section, we'll just look at umbilical manufacturing in general and the challenges, design and engineering challenges that we have with umbilicals. The second part will be taking a close look at a project that we recently delivered to the Middle East. So what is an umbilical? I figured I'd just kind of start at the very basics, just to get everybody on the same page. So I got the API 17E definition here. So basically, an umbilical is a group of functional elements that are all bundled together in basically a conduit, as you will. So we have basically electrical cables, tubes, fiber optics, all in a one bundled basically all in a composite bundle. On the bottom right, we have just an image of an umbilical. Sorry about this, guys. I'm pretty early here today, 5 a.m. So there's only a few umbilical manufacturers in the world, and Aker Solutions is one of them. We have umbilical manufacturing sites in Mobile, Alabama, USA, and in Moss, Norway. So when you talk about manufacturing umbilical, there's two common ways to do this. The biggest difference is how you bundle the umbilical. And on the slide now, basically we have your planetary method, which is the most common, and the oscillate or alternating helix method. So we'll start with the image on the left, or the section on the left, which is planetary. This is the most common. We basically get the functional elements on transportation rails. They're then loaded into what we call a planetary, which is the big disc that you see there in the bottom left picture. Those planetaries spin, and as they spin, you're paying off the functional elements into the umbilical, making the helix. I forgot to mention the key point with a planetary laid up umbilical is all elements are spinning in the same direction. So if you look at the individual elements, they look like a screw thread. So these planetary positions, planetaries have a limited number of positions for functional elements. There's a particular weight limitation on each one of them. So for small umbilicals, you can get it one pass through the machine. For larger umbilicals that exceed the maximum quantity of positions in the planetary, you have to do multiple passes. And we call this a double closing, or even a triple closing if it's large enough. So there's a picture on the left, computer-generated model of an Aker umbilical. Each umbilical manufacturer has slightly different designs and how they make these, but this one on the left is specifically Aker's. So we'll talk a little bit about it. So our umbilicals, if you take a look at, say, a tube there, you can see that it's in its own conduit. There's PVC made up all around it, and each functional element is by itself, so it can act basically independent of others. It can slide or move or pull or push relative to other elements. And what this allows us to do is to have a very long lay length, which is the distance it takes one element to make 360 degrees. That's also equivalent to a low angle, which generates a very low torque. Because there's a low torque, we don't have to torque balance, and we don't have armoring. So the big question that we get all the time, especially for new customers or someone who's unfamiliar with our umbilical, they look at Oceaneering's umbilical and then they look at ours and say, "Well, why don't you have armoring?" And that's basically why. It's not that one is better than the other. It's just the difference that a lot of people don't seem to don't understand. So the alternative method to a planetary closing is what we call oscillate, which is alternating helix. This is a method that's widely used in the industry for umbilicals, primarily for power cables and thermoplastic hose umbilicals. Generally not used for steel tube umbilicals, but with our low lay angle, we're able to do it with steel tube, even larger 1.5 inch steel tubes. So when it comes to design of an umbilical, doesn't matter whether you decide to do planetary layup or oscillate, both basically just the same. The design calculations, everything from one is the same as the other. It's just a question of how do you want to lay it up, and each one has its own advantages and disadvantages. If you look at the bottom right hand of the screen, there's a picture of, say, an aerial photo of the oscillate closing line. And you can see, as opposed to the elements sitting on planetaries and spinning, they're on the ground. They're all pulled off into a single point and into the oscillate building, which is the picture on the bottom left, or right hand side left picture. This is the oscillate machine that puts the twist in it. So you're running a project and you're trying to decide in your planning phase, do you want planetary, oscillate, you have a power umbilical where you say have long length cables and you want to limit the number of splices. Theoretically, with oscillate, you could make a longer length and avoid the splices, which is a failure point theoretically. Also, if you have a complex cross section with more than the number of elements that a planetary machine can hold, you may want to do that oscillate so you can do it in one pass and not have a double closing and increase your risk. All right, so basic design challenges and engineering challenges for umbilicals specific to shallow water and to long lengths. I've noted a few here. The first one that comes to mind, which is almost always something that you have to be concerned about, is the weight to diameter ratio. There's an increased level of influence that the wave action and current action puts on an umbilical when it's in shallow water, as opposed to deeper waters like in the Gulf of Mexico. So you, in order to have a stable umbilical, it really needs to be heavy if you want it stable by itself. And sometimes it gets to a point where you can't get it heavy enough to be stable. So that's always a design challenge of how to stabilize it on the seafloor. The next design challenge is if you're in shallow water, you likely have a shore approach, which means there's some distance that you are dragging the umbilical along the seabed to the hang-off point. There also may be a pull-in through a conduit with a number of bends. These are all things that increase the amount of load on your umbilical that may not be so apparent to you. May not know the length, may not know how close the installation vessel can get to land. So the pull intentions are unknown, and that could be a challenge because you try to design the umbilical so it's, I guess, optimized for strength and weight. And sometimes it's counterproductive to make it stronger just to handle the loads, because you're also trying to, keep the amount of material down for cost reasons. So that's always a challenge. The biggest challenge for the long length aspect of it is how you deliver it. There's two basic ways you deliver an umbilical. One's on a carousel, one's on an installation rail. The carousel is a great method for doing this. However, the loadout costs are very high. You get a long length on a carousel, but then when the installation vessel comes to pick it up, you have to spend a lot of time spooling it. So alternatively, there's an installation reel. The umbilical can be ready there on the quayside, waiting for the installation contractor to come pick it up. Loadout can take half a day. It's very quick. However, the downside is you can only get a limited amount of length on the reel, and if you have a long length in your field, you may have to splice multiple lengths together. So now for the second half of the presentation, this is just taking a closer look at an umbilical we have recently delivered to the Middle East. Not able to share all of the details about the project due to confidentiality, but what I can share is some things that are in the public domain and things that do not violate any of our contractual agreements. So this is a picture of the umbilical that we're going to be looking at. This is on the installation vessel as it was loaded out from our facility. So the cross-section design of this project, so we chose to use the oscillate manufacturing method due to various reasons. Length is one of them. The primary design standards for the umbilical was API 17E, F101, and client specifications that we received. The total length for the whole field is a little over 100 kilometers, split between 4 different umbilicals. There are static umbilicals with topside to topside terminations, meaning both ends are terminated out of the water and not submerged during the design life. The function of the umbilicals is to supply power and communication and injection fluids to the wellhead platforms. The 3 images I have on the right are not all the umbilical cross sections for the project. These are just examples of the type of umbilicals that could that would have the function that this particular field needed. So you have your steel tubes for injection fluids. You have your power cables for power from shore, and fiber optic cables for communication. So here's basically a rough sketch of the typical arrangement of the umbilicals onshore to offshore. It's not by any means drawn to scale. So we can start to the left. Have an umbilical that's pulled in onto a platform and hung off on a J-tube. That's the first topside termination. Then as it goes through the J-tube, it exits at the bottom at some distance above the seafloor. At this region, there's a heavy influence of wave and current on the umbilical at that point, and you risk overbending or overstressing the umbilical there. So it needs to be protected with steel bend restrictors. And integrated into that is a J-tube seal to plug up the bottom of the J-tube, so you can fill it up with corrosion inhibitors. So there's some length that runs along the seabed. In this case, it was a very long length. Then to a conduit that the umbilical was installed through to be pulled into an onshore hang-off location, which may be like it's seen in a vertical orientation, but in this case, it's horizontal. We had a few engineering and design challenges on the project, most of which I've already explained in a previous slide. The biggest one we had was seabed stability. It's shallow water, a lot of wave action. In order to get the umbilical stable in every scenario, it had to be extremely heavy. We did add some weight to the cross section to get it stable for some parts of the field, but in the shallower regions, it's not stable on its own, so it has to have some secondary stabilization. That may be trenching, rock dumping, mattresses, or what have you. And then there's a shallow water pull-in that I suggested in a previous slide, that there's a long length that has to be pulled along the seabed, and at the time of engineering and design phases, that length was unknown, so it was a little bit difficult to try to size the strength of the umbilical and the termination pull-in heads for that installation load. The Middle East has extreme climate. It's very hot, at least compared to here in the U.S. So that has its own challenges, specifically with the next point, high temperatures inside the J-tubes. So you got J-tubes that are acting like a little oven there in the sun, and it's difficult sometimes to dissipate heat from them, especially when you have a power cable with a lot of current going through it, acting basically as a resistive heater. So you could have a situation where the umbilical and the cables inside heat the umbilical up enough to where you're reaching the design limits of the other components, which could be a problem for corrosion or whatnot. So what we've recommended for in this particular case, to mitigate that, is shading the J-tube to keep the sun off of it, or painting it a high color, a bright color, to reflect the heat. My last slide here is just some pictures of the manufacturing operations. Going from the top left, that's our aerial photo of oscillate closing. Going to the bottom left, closing to a single point in the oscillate closing machine where the umbilical is laid up straight, and then going through the twist heads that put the actual pattern into the umbilical. Then closing to an outside carousel in the middle top picture, the inner lane there, you can see the wide umbilical. Then it comes off that carousel, closes into or extrudes through the extruder in the middle bottom picture, and gets your yellow sheathing put on and extruded to an outside carousel in the top right picture. Once it's extruded, the ends are laid down where we can terminate it. You see a steel termination there. There's a potting barrel where all the strength elements are potted in to transfer their load to the termination. Then there's a long, flexible region, flexible pull-in head where the power cables are housed. We need a certain amount of length of cable pigtail to reach the junction box from the hang-off location. And then the bottom right is just a load-out photo of us transpooling the umbilical from the carousels to the installation vessel. So obviously in this case, we chose a carousel loadout. So that concludes this presentation. Thanks everyone. I'll hand it back to Neil.
Neil, you're on mute.
Okay, thank you very much for that, Joe. Good insight there into longer length umbilicals. Our next speakers will be focusing on shorter lengths. Don't forget to post your questions in the Q&A tab, which we will cover after the rest of the speakers. Next is Angus Chain from JDR. Angus is Technical Sales Manager for JDR based in the Middle East. He's a chartered engineer with experience in design, manufacture and supply of subsea umbilicals and cables in various technical and commercial roles. So over to you then, Angus.
Thank you, Neil. Let me just bring up the slides. Is that coming through okay?
Yep.
Okay, thank you. Okay, yeah, so good afternoon, good morning, everyone, depending on which part of the world you're in. So today, on behalf of JDR, I'll be talking about SSIV umbilicals. Firstly, just to thank the SUT and the UMF for organising this event. It's really good to have a spotlight on umbilicals. In particular, I think it's a great time to do it. In the Middle East, we're especially seeing a huge increase in demand for umbilicals, so I think it's great to have a specific event focused on this product. In terms of what I'll discuss today, we'll start off with a brief introduction. I will keep it short about JDR just to set some context about where we're coming from with these products. I'll then discuss what an SSIV umbilical is, and I'll of course explain the acronym for anyone who isn't aware. We'll look at a general SSIV umbilical design. We'll look at the typical scope of supply for the hardware. And then, as the topic for this event is developments in umbilicals, the main development with SSIV umbilicals is the actual increase in the market rather than the technical scope itself. So what I'll touch on at the end is execution essentials in order to handle this latest development and the increase in the volume of these projects. Okay, so firstly about JDR. So we are a world-class provider of technologies and services connecting the global offshore oil and gas and renewable energy industries. So this covers a broad range of products and markets, including subsea umbilicals, both steel tube or thermoplastic hose umbilicals, subsea medium and high voltage power cables, both for oil and gas power transmission or for renewable as well. There's IWOCS systems, which is going to be covered by one of the later speakers today. And then for all of these products, we have the engineered equipment, the hardware that goes with it. And together with that engineering for the hardware, we also have our in-house analysis team that can support with dynamic analysis, thermal analysis, or feed studies and such. And then for all of these products, our offshore service team is there to support the installation, the testing, and the commissioning of the product offshore. And in terms of our manufacturing footprint, so we're based in the UK, and starting with Littleport A here, which is in Cambridgeshire. This is our original manufacturing facility in the UK and is now our smallest, but still plays a crucial role in our product portfolio, in particular for SSIV umbilicals that we'll be discussing today. Because it's not a quayside facility, and because SSIV umbilicals are quite short, as we'll discuss today, it makes it ideal for multiple systems of the same sort of design. We then have Hartlepool in the northeast of England. That's one of our quayside facilities. That's ideal for longer length umbilicals and cables, including steel tube umbilicals that we can load out directly to vessels. And then finally, Blythe. This is a new factory that will be commissioned next year. So that's north of Newcastle, again in the northeast of England. And this is targeted at the subsea HV power cable market. And that will bring in-house, well, into the UK, manufacture the cores and full cable, and again, direct load out to vessels. And just a quick infographic here. This is the product portfolio and industries that we supply to. So whether it be wind farms, FPSOs, platforms, or even other renewable energy sources such as wind or the tidal, connections to shore, subsea, everything to do with subsea umbilicals, cables that JDR can support with. Okay, so moving on to SSIV umbilicals. So firstly, SSIV stands for Subsea Isolation Valve. And this is a valve which, in an emergency scenario, it isolates the platform from hydrocarbon flow. So clearly it's safety critical, both for the personnel and any equipment on the platform, and therefore the timely and correct operation of the valve is essential. And what the SSIV umbilical does is it provides the hydraulic and electrical functionality in order to operate and control that valve and ensure that it's correctly closed. So because the SSIV umbilical has a fairly limited operational requirement, it's a very important requirement. As I said, it's safety critical, but it's a specific purpose. So what that means is that there's less components than you may see for other umbilicals, where they'll be forming a range of other functionality. So the components are quite simple, and on the right here you'll see a cross section of the umbilical, which is what you'd see if you cut through the umbilical. And so we have hydraulic lines, and we have low voltage electrical lines. In terms of the hydraulic hoses, these are, well, they're almost always hoses because they're only performing hydraulic function. So there's not really any necessity for them to be steel tube. And then in particular in the Middle East with the shallow water, it's unusual for us to have a requirement where tube is necessary. And in terms of the power, these will be low voltage cables. And there's usually a low number of these components, but it's worth noting that because of the safety critical nature, there's quite often spares or contingency included within the quantities in the umbilical. Fibre optics are often included within umbilicals, but for SSIV designs, they're not. Any sort of the control or communication is handled as part of the cables that are already there, the electrical ones. And as I mentioned at the start, the length of these umbilicals is quite short, as the valves are in a relatively close position to the platform. So quite often they'll be less than 1 kilometer long, maybe 500 meters, but they can, depending on the field layout, they could be longer, but usually we wouldn't expect to see an SSIV umbilical more than, say, 5 kilometers. And following on from something Joe mentioned as well in his presentation, particularly in the shallow water in the Middle East, you'll see that the stability of these bundles is quite challenging because they don't have many components, and because they're lightweight components, it's often necessary to add a lot of weight to the bundle in order to provide stability. But we do also see that with the umbilical being so small and light, sometimes that can be counterproductive, and it's not actually possible to achieve the necessary stability with the umbilical alone, and it can be better to stabilize using external means such as mattressing or ballast modules, or even rock dumping, that sort of thing. So in terms of the sort of typical hardware scope of supply, so it's quite a straightforward and simple scope. It's something that's quite typical for most umbilical projects for platform connections. So starting from the top and working our way down briefly. So we have electrical and hydraulic junction boxes. They connect the umbilical tails to the topside platform connections. We have the pulling heads. So this is how the umbilical is handled. It's how it's installed to subsea, and then the pulling heads attached to a winch wire and pulled through the J-tube to the topside location. And at that point, a hang-off is used, which is the mechanical termination on the umbilical that supports the load at the top of the J-tube for the design life. Subsea, we have a J-tube seal or centralizer that positions the umbilical at the bottom of the J-tube. And in the case of the seal, it prevents any exchange of fluid between the seawater and the J-tube inhibitor. And then going to the subsea end of the umbilical, we have the subsea umbilical termination unit, quite often called a SUTU, sometimes maybe called a SUTAP, depending on your acronym preference. So this is what's used to install the umbilical to the valve location. So within this metallic structure, there'll be termination of the hoses and cables via subsea couplers and connectors onto a bulkhead plate. And then that's used to position the mechanical termination at the location of the valve. And the final connection from the SUTU to the valve actuator is made via hydraulic flying leads and electrical flying leads, sometimes referred to as patch umbilicals as well. And these will all have subsea couplers and connectors to interface between the SUTA and the valve actuator. And that's quite a key interface to ensure is correct. So it's quite common that the couplers and connectors would be within the umbilical scope to ensure that they fit up correctly when installed subsea. Okay, so finally, I wanted to touch on some essentials for successful project execution. So as I mentioned at the start, this is the real development that we've seen in this product market, because the umbilical scope and the hardware scope of supply, as I think you've seen in the previous slides, are fairly straightforward. Really, the change we've seen is the much higher demand for these projects, and it's potentially fivefold, if not higher, in terms of the increase we've seen in the Middle East for SSIV umbilicals, and that's being very largely driven by Aramco currently, through their CRPO project release program. There's a number of SSIV umbilicals as part of that. So with that in mind, the considerations in order to successfully deliver an SSIV project are quite different when the scales are increased massively. So the points that we would highlight as key to handle this increased scale are the following three. So we have supply chain control. So in-house manufacture of umbilical components is very beneficial, because we've seen lately through the pandemic how unforeseen supply issues can impact. Having the cables and hoses in-house gives massive control over that, and especially when the umbilical itself has a limited number of components, it means that you essentially have full control over the umbilical supply. And also the hardware is very important on these projects, as it makes up a large part of the actual project supply. So it's essential to have suppliers that are local, either to the umbilical manufacturer or potentially to the delivery location, in order to ensure that quality control is good and also to ensure timely delivery. Repeatability in system design is very important for these projects. The first point here is to avoid multiple design variants, and this is very important because of the benefits it can have. So if you consider an umbilical, you had a project with multiple umbilicals, and perhaps you wanted to remove one or two hoses or cables from one design to save some cost. In reality, the saving from the material is far outweighed by the impact onto the engineering and having multiple designs and everything that has on the project execution. Because the umbilicals are quite small, it's much better to have the same design across all. It expedites the delivery and simplifies everything on the project. And similarly with the hardware designs, because these projects are quite straightforward in terms of the scope, you know, they've been supplied to the region for over 15 years. It's best to have standard designs that have been optimized during time for the best engineering efficiency, rather than repeatedly designing on each project. And following on from the fact that they've been supplied to this region for over 15 years, it's also key to take forward experience in field proven designs. So utilizing installation methods that have been employed in the field previously. Usually we're working on projects where there's an extension of an existing field. So it's likely that some analysis has been done that can be carried forward, and the same methodology can be used rather than having to change hardware designs, which might be required if the installation method is different. And also it's worth noting that the reliability of these designs is critical, not only for the safety critical nature of the SSIV, but also when we consider this increased demand and the fact that they're intended to be repeatable systems with the same designs copied across, where if there was any issues that may come up in one design, the impact of that is going to be magnitude across multiple systems. So it's really important to have tried and tested and reliable designs. So these points, together with our multiple manufacturing sites, are what enable JDR to execute many SSIV umbilical projects in parallel, and that's the development that we've seen in this aspect of the market. So that concludes my part of the presentation. Thank you for listening, and I'll hand back to Neil.
Okay, thank you, Angus, for your presentation on SSIV umbilicals and the associated hardware. It's important to note there from Angus, although they're short in length, due to the hardware needed, each umbilical is a fully fledged system in itself. Again, just reminding you, any questions you might have, please drop them down into the Q&A tab and we'll pick them up at the end. Next up is Richard Ball from Fibron. Richard started his umbilical journey at JDR in 2008, held many roles, including within engineering and project management, before now working as technical sales manager at Fibron, where he has been for the last 4 years. So over to you then, Richard.
Thanks, Neil. Let me just share my screen. Hopefully everyone can see that. Right, so I'm here today to talk about IWOCS umbilicals and IWOCS as a whole. We'll be going through what an IWOCS is, talking through the acronym, just for those of you who don't know, what an IWOCS comprises of, and then looking more in detail about what an IWOCS umbilical is, how an IWOCS umbilical is deployed, and then briefly looking at some recent developments that Fibron has been involved with. Before we get into it though, just a quick overview of Fibron and its product range. So there's quite a lot on that screen that you can see in terms of Fibron's product portfolio. So we supply into the oil and gas market, IWOCS umbilical systems, obviously, production control umbilicals, SSIV umbilicals, buoy-to-plumb umbilicals, and jumpers, EFLs and HFLs and the like. We also supply into the geophysical survey industry, ROV umbilicals, as well as into the defense market, and we supply life support umbilicals into for sort of commercial diving applications as well. So there's quite a lot of a vast product portfolio that Fibron has, and IWOCS is quite a small chunk of that product portfolio, but it's quite a large overall value stream for Fibron. Fibron's currently the market leader in IWOCS umbilicals. So for just some context, and for those of you who are not familiar with the term IWOCS, what does IWOCS stand for? So IWOCS stands for Installation, Workover and Control System. Sometimes that the word installation is interchangeable with intervention, because it all depends on sort of the stage in the process of a subsea well completion or an intervention. But generally, installation, workover, and control system. So what is an IWOCS workover? What is an installation, workover, and control system? Essentially, an IWOCS is a package of equipment for use offshore and subsea. It allows the user to install or intervene, for example, maintenance or repair purposes, and to complete work on subsea wells and subsea hardware or infrastructure. Sort of in the Middle East, where you're looking at very shallow waters, subsea completions aren't too common, but if you did sort of step out from a platform and need a well sort of 2 to 3 kilometers away or even further, you would then use an IWOCS to install that well and Christmas tree and hardware. So what does an IWOCS package contain? So an IWOCS package contains an umbilical and reeler system. So that's a reeler which contains the umbilical on it. You can see that there in the background on the picture on the right. It contains the topside control package, chemical injection units, as well as ancillary equipment like tooling, other winches, clamps for clamping the umbilical to the marine riser, and also potentially heave compensation systems depending on the work being carried out. These reels are either pneumatically driven, electrically driven, or hydraulically driven, again depending on the project requirement or what utilities are available on the vessel. And all of the communication from the top to the bottom is all performed through the umbilical. So all the hydraulic control, chemical injection, the communications, and the monitoring is all done from topside through the umbilical when it's intervening or installing the subsea architecture. So these packages are deployed in both shallow and deep water installations. Obviously, in ultra deep water applications, the umbilical needs to be designed adequately to cope with the pressures seen at depth. So looking more into the umbilical itself, so what is an IWOCS umbilical? Joe represented this quite well on the sort of production and control umbilical side of things, but again, it's essentially a number of components twisted together, electrical cables, fibre optics, and thermoplastic hoses into a flexible bundle. The bundle is then extruded with an inner sheath of polyurethane, typically reinforced with Vectran's braid, and then a final outer sheath of polyurethane is applied over the whole bundle to give it some further protection. These are flexible, very, very flexible umbilicals, whereas the umbilicals that you've seen so far, because they're permanently installed, they are reinforced with a contra-helical layer of armor, whereas these IWOCS umbilicals are reinforced with a Vectran braid to give it some to give it the flexibility as well, to allow it to have some flexibility. These are typically used in operation for sort of two weeks or so as they complete a well. And again, like I said, they need to be very flexible. So I think I mentioned already, they're used as the link between the topside and the subsea equipment. And because of the various stages of installing a subsea well or a Christmas tree or just a subsea completion in general, there are many different IWOCS umbilicals that are supplied. Generally, they have similar functionality, but some specific umbilicals perform specific tasks. Like you can see there, an XT umbilical generally is the largest of the whole lot, and it contains quite a lot of the functionality to complete and finish off Christmas tree installations. LS umbilicals are for landing string installations, tubing hanger umbilicals, lubricator valve umbilicals, annulus, and BOP umbilicals. So again, depending on the stage of installation of the subsea well or an intervention, requires different functionality for the umbilical to allow the user to intervene or install. So the umbilicals comprise of thermoplastic hoses. There aren't steel tubes in these. It will be too stiff, and the MVR will be very, very high. So typically the hydraulic control is done through thermoplastic hoses along with chemical injection. Power and comms are done through low voltage cables, and you can have fibre optics within the umbilical for communication purposes as well. So like I've mentioned, the inner sheath and the outer sheath are typically polyurethane material to provide flexibility, but there are alternative materials depending on where the umbilical reeler system is located, depending on the project requirements. So you could sheathe the umbilical in PE or thermoplastic rubber, for example, but generally it's a polyurethane, and the strength is provided by the Vectran braid. So this slide here shows you a sort of a cut through of an actual IWOCS umbilical. You can see the inner bundle here, the outer bundle, which is applied in the contrahelical direction to the inner, and then you've got the inner and outer sheaths, and you can just about see the strength braid, the Vectran strength braid there. So these are very different to the permanently installed umbilicals that you've just seen and presentations on, purely because of the application these are used in. So looking at the hoses, thermoplastic hoses with sort of either collapse resistant requirements or non-collapse resistant requirements, again depending on the depth required for the installation or intervention. Various liner materials are used, so you've got nylon, typically nylon 11, but then you've got access to sort of polyethylene lined hoses, as well as some other hose manufacturer includes sort of their own proprietary high temperature and more chemically resistant liner materials. Hoses are typically reinforced with aramid fibre to give the burst reinforcement, and there are specialist hoses out there which utilize a spiralized steel reinforcement. These are typically for sort of low volumetric expansion requirements. But any umbilical that are using these hoses will have them all qualified to API and ISO, which are the requisite standards. Low voltage cables then. So typically in an IWOCS umbilical, you'll have a pair or a quad, 2.5 square mil pair or quad. But there are sort of other layups, multi-core layups that are used as well. Again, designed to the requisite standards, API and ISO. Likewise with fibre optics, these can be included in the umbilical if required for communication purposes. So how is an IWOCS umbilical deployed? As mentioned, these umbilicals are stored on reeler systems sized to suit the MBR of the umbilical, as well as the length required. They're electrically driven or hydraulically driven or pneumatically driven, again depending on the loading requirements for the project. Sometimes customers have an overlength to allow them to be used in multiple locations, not just in the field that they'll be first installing. So they may want to use this on different locations or different fields which have different depths. And these IWOCS are routed from where the reeler system is located on the back of the vessel. They are routed over roller box sheaves to either the moon pool or the sort of overboarding location, essentially where the subsea package is going to be lowered from. So at the subsea end of the umbilical, as it's routed from the reeler system over the roller box sheaves to the overboarding location, there will be a subsea termination unit or a subsea termination. Again, there are so many different types depending on where the umbilical is going, in riser, out riser, whatever function it's going, and how much space constraints there are around where the termination is going to be. But generally, the end of the umbilical will get terminated to the subsea package before the whole thing is lowered down. And so as the subsea package is lowered down through the moon pool or over the side of the vessel, the umbilical is then clamped to the marine riser or the drill pipe or wireline with clamps at regular intervals to sort of reduce any loading on the umbilical. Again, there are many different sort of stages to the installation and the well completion. So a lot of literature out there if you're interested in that sort of thing. So once the subsea package is lowered, connected in or installed, and they're ready to complete and move on to the next location, they will take the whole marine riser back up along with the umbilical, where the umbilical gets reeled back onto the reeler system, and they'll move on to the next location. So in terms of IWOCS developments then, projects are getting deeper, temperature requirements getting higher, pressure requirements getting higher too. There have been a couple of developments in terms of IWOCS umbilicals over the last couple of years. So Fibron has supplied its first 20K system, and that was to Schlumberger back in 2021, and this was for a landing string system. We worked with our hose manufacturers to get a fully qualified 20K hose. We work with Spearstar and Parker, who supply the spiralized steel reinforced hoses. We're also working with other technology suppliers to develop the IWOCS umbilicals further. And recently we've supplied a sort of a long-term intervention umbilical where the customers needed to use a very flexible but sort of potentially temporary solution for their development, and the IWOCS umbilical was reeled down, connected into the subsea equipment, and operated potentially up to sort of a year or two, but potentially as quickly as a couple of months. So thanks for listening. Contact details are there should you need them. But yeah, there's a lot around IWOCS systems, not generally used a lot of the time in the Middle East, but you will need to use an IWOCS system if you do have a subsea intervention or installation. Thanks, and back to you, Neil.
Okay, thank you, Richard. I guess just picking up on that last point there, it's important to note that as much as the different umbilical types, whether it be production control umbilicals, SSIVs or IWOCS can be, you know, there are similarities in terms of design considerations and manufacturing techniques between them. So last call there for questions. If you've got any, put them into the Q&A tab and we'll cover them after this, our last speaker. So introducing our last speaker, Fraser Thomson, speaking on behalf of the UMF, but Fraser has worked for Oceaneering for over 30 years in many different technical roles and currently as principal engineer. So over to you then, Fraser.
Thank you, Neil. Let me just save my presentation. Yeah, thanks, Neil, for that kind introduction. Appreciated. So, as you say, the presentation's on behalf of UMF, not Oceaneering that I work for. But I've had the pleasure of being active in the UMF for over 20 years, and combined with Oceaneering experience, I've seen many issues that could be avoided, just like all incidents, you know, technical issues. They're just the same as safety issues. They can all be avoided in some. So hopefully today's session is aimed to try and help improve our customers by bringing awareness and to mitigate the major risk in the umbilical life cycle. I mean, that's from contract through to operation, through the experience of the UMF, by altering the focus of quality and resources and engineering risk management to balance that with the risk tariff during the life cycle. So this is experience we can't get as individual manufacturing facilities. This is the experience you get when all the manufacturers come together and share information. Unfortunately, a lot of that information is desensitized. So in terms of the visual aspect today, we have to minimise what we share there, but nevertheless the message I think is important to try and get across. And please understand that the UMF, I know there's a lot of the operators and installers on the call today, and we do respect, you know, that many are experienced and very professional and balanced in terms of their approach. And have improved and lowered the risks over the years. But this presentation is mainly intended to help those less experienced and assist in a continual path of industry improvement, you know, of quality and reliability that the Umbilical Manufacturers Federation serve the industry with. So please don't shoot the messenger today. Thank you. Let me just move on to that. So let me tell you a little bit about the UMF. Neil talked about that earlier on. So UMF represents a large section of the global umbilical manufacturers. And you can see at the bottom there, we've got Aker, Fibron, JDR, Nexans and Oceaneering. So that's a large percentage of the global umbilical supply market. We meet regularly every quarter or so, every year, to ensure we're supporting the industry and that our product reputation is maintained mainly in terms of safety and reliability. So Neil shared a little bit about the goals of the UMF, but they're really to ensure that the umbilical manufacturers supply our products safely and suitable for successful installation and reliable operation. And we have to do that in a non-competitive way. So the first thing is, of course, as always, number one, safety is our number one goal. We share safety aspects. It's a non-competitive thing, which is good. And since most of our processes and plants are similar, we can share desensitized lessons learned, trying to keep all our personnel safe and possible, and certainly not to repeat any incidents that others have had, others in our own plants and others in our other umbilical plants. It doesn't do the industry any good. Our latest work focuses on steel tube umbilical processing because of the stored energy that's involved there, to prevent injuries from that significant energy level that we do when trying producing steel tubes of the lengths we do today. So yeah, improve umbilical operational reliability. We want making sure the products that leave our plants go out are installed correctly and don't compromise the operational reliability performance. These products are designed and manufactured to last in excess of 25 years, and that's a challenge in itself. So these products have got to be high quality and they have to have good designs, and they cannot be abused at all because of their sensitivity and their value. So this comes on to, yeah, we want to reduce umbilical installation failures. We want to make sure that we spend all this time and effort building these umbilicals, and we want to make sure that they're installed problematically free. We also support the international standards for our products, the API 17E, ISO 13682-5, trying to ensure they reflect the needs of the market. So they're good there. They have some lessons learned, and they're a good guide to the industry how to try and make an umbilical purchase as good as it can be. So we want to make that standard as good as it can be. And the API standard guides those less experienced in these practices, but the bottom line is it doesn't protect you. It doesn't cover everything, and it doesn't guarantee complete project success. So the UMF tried to address some of the gaps in the standard to enhance just guidance and understanding. So we've done that on a few things. Neil talked about earlier on. We've got our own website. We've generated some guidance notes. These guidance notes typically cover things that are not well covered in the standard. Hopefully they'll then move into the standard as we improve them from revision to revision. So we've got data sheets, free span analysis. We've got just information documents on a steel tube versus thermoplastic, manufacturer installer interface guidelines, storage guidelines, standard template for umbilical installation parameters, and the most recent one, impact testing. So there's a lot of information there that's not covered in the standard, that's not necessarily in the public domain, that can help you. So let's talk about the next slide covers about some of the awareness that we share within the APM, within the task group. So we share the sensitive information to make sure that we don't repeat some of the mistakes, because these umbilicals are very specialized. They're very custom, they're very high quality, high value products, and we produce them in low volume. So some of these mistakes in the manufacturing plant, of course, happen, and of course our plants are not perfect, but normally on a project basis, issues that arise during the design, manufacture and test can often be overcome with little or no impact to the purchaser's overall project schedule and cost. So yeah, I know it's a pain and burden for the plants, but in terms of the purchaser, yeah, I know, you know, schedule is an aspect and added cost is an aspect, but typically these are overcome, and that's not where all our problems lie. So, as I say, the problems in the plant are not historical. They're not historically where our major problems lie. And in terms of ordering us to help protect managers, your project managers as well as engineers and schedulers to plan for project success, we've got to do everything possible to try and reduce these risks. Issues and concerns in manufacturing rarely manifest themselves during the operation and installation. So, but if you compare the quality aspects of balance between manufacture and installation and operation, well, the manufacturer's got all these steps, and there's many controls there. There's starting of the processes, inspections, and the various stages where we can investigate and even correct if needed, compared to the higher singular risk during the continuous process to that of installation. You know, it's done once, it has to go perfect from start to finish without compromise. So the installation process is a really nervous time, and it's rare where the product that you buy takes more to install than the product itself. So maybe that's where we should focus. So as I say, we've taken some information, and I say there's not a lot of detail here, but just take this as some level of guidance. And there's a lot of umbilicals supplied over the world, so this is a low percentage. Don't get me wrong. So yeah, we've had some problems during operation, which you would expect, but the majority of the problems in terms of the overall life cycle that is serious occurs during the installation process. And this is where some of the umbilicals have even had to be replaced, or some of the functions independently replaced. So like a smaller umbilical with smaller functions piggybacked onto the existing system. And also some of the redundancy with the designs being consumed. So the installation went okay, but we've had to use some of the other functions to supplement. So no longer the redundancies within the product that a lot of customers include in the designs, knowing that if they do have some reliability concerns or issues, they can change to other products, other functional components within the design. But the bottom line is they can all be avoided. The other part is historically and unfortunately, a lot of our installation vessels and experience is all related to like pipelines and flow lines. But the umbilicals have far more sensitivity to failure than any of the other products, and they've all got to be installed at the same time. So the umbilicals have got to accept the umbilicals as part of the offshore install scope and accept that associated high risk. And the failures during that installation process tend to be from unexpected and unplanned risks, and the fact that the umbilicals are less robust for the following reasons make it quite sensitive. So an umbilical's got low stiffness to protect itself from overbend and load control. So if it's just hangs down, being connected at tight corners, it's going to overbend itself. Whereas a pipeline or is far more stiff, can protect itself and like the flexible flow line, has far lower minimum bend radii. It's got low crush resistance, so if we over crush this, inadvertently crush it because of catch it between items of hardware, or don't have a caterpillar set correctly or designed correctly, we could exceed the crush resistance. But our products are low in crush resistance and very sensitive compared to the other products that are typically installed. And if we're doing large bore steel tube umbilicals, they've got a really high bend radius that's got to be respected. So it's like a small, you know, in terms of its diameter to bend radii ratio is relatively small and quite sensitive to handle. Also, it's got low compressive buckling resistance. So, you know, when you compress this umbilical axially, then there's a good chance it can buckle if you lose control of the process. And low torsional buckling resistance due to that high torsional stiffness and the low bend stiffness, the aspect combination of these two things. So yeah, if you take the umbilical and if you put twist into it, because it's not that stiff, it can buckle on itself quite easily, like throw a loop or so. Just move on to the next slide. So I was wanted to talk about the just a little bit about the umbilical performance there in terms of the suitability of the equipment. We talked about the vessels typically designed not for umbilicals but for other products, pipelines and flexible flow lines. And on top of that, a lot of the things that handle the umbilical, for instance, you know, the caterpillars. In our plant, we've got multiple long length caterpillars that are soft and compliant, multiple tracks. Each track is individually controlled with pressure. So basically, independent of what shape is going through the caterpillar, the same contact pressure is applied by all the pads across the umbilical system. And some of the vessels have been upgraded to do this, but some have just got single short length caterpillars designed for pipelines with maybe only 2 tracks, but massive compression loads on them. So it's important to assess the sensitivity of the product for the installation. Now, talking about just some of these handling failures, we can only go over a few of them, of course. So as you'd imagine, because of the product having that inability to protect itself from overbending, this can happen. Compression buckling, like we talked about earlier on, this often happens when we lose the touchdown point via the ROV during the installation process. We crush the umbilical, we squash it between 2 items that it's not designed or meant to have been in contact with. We twist the umbilical because we've not planned the route into the vessel carousel, or the bends of the route leaving the payoff on the vessel to the overboarding chute. And general mechanical damage, things going wrong in the overall handling process. We also have certain issues with end connections at the interfaces, and this is an area the industry needs to work on and improve. So we've had interfaces and connections break, so uncontrolled drop end of an umbilical. How bizarre is that? Mechanical failure of end connections, so just physically breaking or not rotating or not performing their function. Interface errors, as you can imagine, these 2 things have to come together. And then, of course, hydraulic leaks. So yeah, they're quite varied. The other part we've got often is we don't often understand the umbilical itself. Often the umbilicals are purchased with a timeline where the umbilical's actual performance is unknown, or it's known too late, or the headroom that's not been tested to know, which is really important for robustness for when we have abnormal and unplanned events. These products are sensitive, and we've got to handle them carefully. And unplanned events, abnormal events, can be damaging depending on what they are, depending on the overcapacity that happens to be in that particular umbilical design. So the installation is unique. Remember, it's not rehearsed. We do this all the time in our manufacturing processes, and it's a one-off operation. So the installation is a very difficult thing to do, a difficult, sensitive thing to do. I know it's difficult being an umbilical manufacturer, but please understand it's very difficult to be an installer, particularly an installer of umbilicals and the associated risk that comes with them. To know about the umbilical and its capabilities, prototype testing prior to the umbilical manufacture are rare. Very few purchasers of umbilicals actually have the cost and the time to try and do the qualification testing on the umbilical to make sure that anything that contacts or touches the product is actually qualified correctly and they understand the level of robustness. So there's more onus on historical test data and like some of the modeling analysis, the 2D, 3D modeling analysis that we do nowadays. So yeah, so more emphasis on the installation analysis is also needed. So we need to balance this compared to all the details that and all the quality standard that we do with our umbilical manufacture. It needs to be balanced, and I don't think it's balanced today. So the installation analysis is really important, and often the installers do that on their own, but they really should do that very closely in recommendation. In conjunction with the manufacturer's recommendations. So we've got just some recommendations for project success we'll quickly go over. So just talked about the whole basis of this slide is balance of resources and quality across manufacture and installation. So yeah, make sure it is balanced. And what the UMF's experience is, it's not balanced, and we need to spend more time and effort at particularly on the installation phase. And if you can imagine, the plants they're more focused on making the product, but the plants are actually the best group to be able to assist the installers in reducing risk. So more emphasis on the installation analysis, the preparation for this and the procedures and any of the qualification that's needed for that process. So, this needs to be considered differently by the project managers, particularly the purchasing project managers, and even in the scheduling side of it. Top of that, in this region we're talking about today, there's quite a few things that are novel and new in terms of installing. The shallow water, seabed stability, meeting land, etc. So focus on these things because they are high risks. And try to, I'm saying qualify, so that's physically qualify, if not analyze, everything that's not already been performed or qualified that contacts the umbilical, that grips the umbilical, bends the umbilical, clamps it, deforms it, pulls or interfaces with the umbilical. It's kind of like a tick check, just go over everything that the installer does there and just check with the manufacturer that it's qualified. One thing that is maybe it's a bit of a sidetrack from this presentation is, but there is a trend over the last 30 years for the older systems to struggle for electrical insulation. And our recommendation is please measure the installation before, after the installation, and more importantly, put the equipment in place to measure it during operation. You need to monitor your low voltage cable's electrical function to make sure reliability is there. And even though we're still trying to figure out what the absolute root cause of the design is, and don't let me panic you all here, all the systems up and running and working well generally. But we've found that this is a system, so we've got to use the same cable design and the same quality throughout the system, the same connectors throughout the system to help you, if you do have problems with installation, to track it down and to minimize problems with insulation. Sorry, I said installation prior to that. On the vessel, you want to optimize the install process route, and then you want to control and measure it, and also measure the twist in the process. So if you've got multiple options, installed process routes, the umbilical manufacturer can help you with that, minimizing the arduousness and the risk of that process. So I had the installation analysis and the installation procedure review into the umbilical supplier's project schedule. So that forces you to go through that together and make sure that the umbilical manufacturer and the installer are happy and mutually agreed on that. Now, the reason for that is that the umbilical manufacturer can add a lot of value to this process, so don't isolate them from that. Remember and clarify umbilical performance and characteristics and the definitions. We've had various working sessions and working groups with the installers, and we've not got complete clarity across our umbilical manufacturing organisation that we use characteristics that are not defined in the API standard, and also we define some of the characteristics differently, and they're tested and qualified differently. So when you're looking at the main parameters from umbilical, make sure you understand these parameters and where they come from. So risk review for each activity and add contingency plans for any unplanned events. What we've seen is typically everything's just assumed to go hunky-dory often, and this is not, there's obviously differences between those that have been there before and lessons learned, but we all don't share lessons learned within the umbilical installation fraternity. So make sure you analyze abnormal and extreme cases, including recovery. So we've seen a couple of times where umbilical designs have actually been designed incapable of being recovered from a certain direction. So it's something to include into your contract notes, and something to make sure that it's designed and capable of. Review and improve monitoring and recording. So this is caterpillar settings on the vessel. This is the twist of the umbilical, etc. So work with the manufacturers to make sure that the installation is monitoring everything. In the event there's a problem, we've got the information to go back and look and see. And typically when you do that, you make sure that you improve the records, you improve the clarity of communication and the settings, and risk goes down. So yeah, the final message there really is just use the umbilical manufacturer's experience to minimize the installation risk. They can play a big part in this whole process. Just don't forget about them. Don't leave them to the last minute. And I'll give you some examples, even Oceaneering have had. We had a vessel turn up.
Fraser, I think we've overrun. If we could hold the examples and
okay, no problem.
Go on to, yeah.
That's fine, Neil. I'm finished. I had 6 examples. I was finished.
Well, thank you very much.
Thank you, Neil.
Yeah. Thank you very much, Fraser. That's really interesting insight there into the into the installation side of umbilicals, which is equally as important as the manufacturing and design specifications. So thank you, Fraser, and thank you to all of the speakers today. What we'd like to do now is take a look at some of the questions that have been posted and see if we can offer some answers in these last 15 minutes before wrapping up. So without further ado, let's get on to some questions. One for you, Joe. Does oscillate method improve delivery time? Or I guess what is the benefit briefly of oscillate method?
Yeah, good question. It could improve delivery time. It just depends on a case-by-case basis. For instance, if you have an umbilical that has more elements than can fit in the planetary machine, you can limit the closing operations to 1 pass as opposed to 2. So you can save a few weeks, maybe months, or maybe a month there. So that's one way it could. Second way is having 2 bundling lines opens up your possibilities for your schedule. closing is basically the bottleneck of the umbilical manufacturing operation. So just having a second line, you're able to juggle, customers' products around where you can fit the closing slot where you need it to fit for your schedule. So the answer to that is yes, sometimes.
Okay. Well, I guess okay. And what sort of parameters do we believe? And I guess let's put this to Richard. What sort of parameters do we need to be quoted for ordering umbilicals? What are the key parameters that you guys need to know as umbilical manufacturers?
So obviously what the umbilical is going to have in it, so functionality, and then that in itself, types of hoses, size of hose, pressures, in terms of cables, size of the conductors, voltage rating, insulation material, maybe if they want something specific, screening, and then fiber optics, number of fibers, fiber type, multi-mode or single mode, or yeah, and then obviously if there's an OD restraint, sometimes they might want to just put that on us, and other times it's the need for it to be seabed stable, which has been covered quite a lot by both Angus and Joe. Length, and if there's a specific diameter to weight ratio, sometimes if it's being installed in a dynamic configuration. There's a lot, I guess, but generally, functionality, length, and then we can start trying to figure out how to package that up in an umbilical design.
Okay, that's good. I mean, there's a lot that's required. The API standards give us guidance, don't they, on the kind of things for us to consider. But I guess they're the key ones. I guess another question for you there, Joe. Steel tubes, yeah. So do they not provide a faster valve actuation response due to not having the elastic expansion properties of thermoplastic hoses? Do you find that? What's the main reason why you would put steel tubes into an umbilical rather than thermoplastic hoses?
I'd say the main reason is design life, durability. In regards to valve actuation, I'm not sure I'm the right person to answer that question. I know very little about that subject, to be honest. So maybe I'll defer to some others.
I can help there. I mean, with steel tube, there's no accumulation effect. So essentially, you have to have subsea accumulators with steel tubes for fast valve actuation. With the thermoplastic hose, you do have it's its own accumulator to some extent. So yeah, steel tubes have got a number of advantages, like we've just suggested, but you've got to put subsea accumulation there for fast actuation speed.
I was involved in a project. Sorry, Neil, I was involved in a project where there were some umbilicals, half had thermoplastic hoses and half had steel tube, purely because the length deemed it necessary for the expansion requirement. So yeah, all depends on. Yeah.
And I guess there's a couple of questions that lead on from this. I think sticking with you there, Richard. You've mentioned Spearstar and Parker in your presentation for IWOCS umbilicals. Is it not the case that one of the reasons for using those steel spiralized hoses is to limit that expansion?
Yeah, in the IWOCS umbilicals, that's right. Sometimes there is a low VE requirement. The specifics on that in terms of valve actuation timings and reasons why, I'm not 100% sure, because it's all dependent on the subsea equipment being controlled. But yeah, certainly, even though those are sort of 3 kilometer lengths, there are low VE requirements in IWOCS umbilicals. Yeah. And that's where you would use the Parker hoses, because they are a lot more flexible than a steel tube. Yeah.
Yes. Yeah. They offer that compromise. Yeah. So Angus, along a similar theme, we have a question here for SSIV umbilicals. Typically 5 kilometer length. How do we meet the valve closing time requirements to meet the safety requirements there?
Yeah, so I mentioned the 5 kilometer length just as a maximum, really to highlight that. No, I mean, other umbilicals could be much longer. I know Joe mentioned up to 160 kilometers in a single length in his presentation. So it was just to highlight that they're at the shorter end of the umbilical scale in terms of length, and most of the time we'll see them less than 1 kilometer, maybe 500 meters long. And so really it just depends on the system control to look at whether the valve closing time is sufficient, and I expect that if it wasn't, that they would move the valve closer to make it viable.
Yeah, I guess these are relatively short length umbilicals, aren't they? So the volumetric expansion of thermoplastic hoses is quite small in comparison to production lengths. Yeah. Yeah,
exactly. I mean, volumetric expansion is of course a consideration between steel tube and hose, but really we wouldn't expect that to start playing any sort of consideration at these sort of lengths. It would be more, say, 20 kilometers or above, where we would be suggesting that at least the system control vendor, whoever that is, has a review of that.
Okay. And just going back to yourself, Joe, and possibly Fraser as well. So with oscillate, there's a lot of interest here in oscillate. Does it provide improvement to or limit, in fact, the tension capacity of the umbilical in any way?
I'll take that one first from my side. In regards to installation capacity, there's no difference between the oscillate and planetary bundling. And for shallow water, you wouldn't see really any difference in application. For deep water applications where you have a long-term load, there are some additional checks that we'd have to do. So there is a possibility that it would be limited in that case.
Okay. Is there anything more you wanted to add to that, Fraser, or has that answered it?
Yeah, no, I mean it's a technique that Aker use that's principally there. So I know the technique works and it's a very good process. So yeah, we understand and support it, but we don't have much experience because we don't use it. So
all things considered, here's a question for everybody that we'll split up. So all things considered, typical lead times for for first of all a production control umbilical. Fraser, Joe, what are we looking at there?
It's 6 months to 2 years, depending on the size and scope, availability and plant capacity, and material supply. Material supply has been a big thing recently after COVID. So yeah, it's
yeah.
But yeah, you have to plan for it, prepare for it well in advance.
And Angus, for SSIVs?
Yeah, so SSIVs, anywhere from say 9 months for a single system, depending on capacity, up to 12 or more months if it's a larger volume project. And I think just touching on the production umbilicals as well, I think the key difference there is depending on the materials that we use. Recently, we've seen some steel tube suppliers exit the market, so that has provided a much more constrained supply route for that part. So we've seen the lead times push out dramatically. So for steel tube projects, it's almost entirely driven by the steel tube supply itself. Whereas when we have thermoplastic hose, we're able to avoid that constrained supply. So that makes a big difference in terms of material selection.
Brilliant. Well, thank you very much. Well, unfortunately, guys, we've run out of time here. So I'm just going to say, thank you to all the speakers there, and thank you all for the questions that have come in. In closing, for the UMF, I'd like to thank the sponsors, from Aker, Oceaneering, Fibron, and JDR for their insight, and I'd like to thank also Adrian and the SUT for organising this event. And I'd like to also thank you all for taking the time to attend today, and I hope you have found this interesting and insightful. And I'd like to just hand over now to Adrian for final thoughts.
Yeah, thank you very much, Neil, and a big thanks to speakers and sponsors. It's been a fantastic event. I mean, from our perspective, sitting here in the Middle East, the market for umbilicals has absolutely exploded. Not only the SSIV side of things, but also there are 4 very long umbilicals sitting just off a quayside somewhere in Abu Dhabi, which has just been delivered by Aker Solutions. So it's a really interesting topic. An EPC contractor said to me 2 years ago, there's just not enough capacity in the market. That's why we're bringing in people like Fibron, Oceaneering. I mean, you know, there's just plenty to go at, and I think what we wanted to do and what the SUT is focused on is bringing the market together, or at least the technology together, and talking about, you know, some of the issues of manufacturing and deliverability. Just before I conclude, I mean, the market is just incredibly busy from a kind of tier 1 EPC contractor, both Aramco, ADNOC and Qatargas. There's just no shortage of projects and work out there on the horizon. As the SUT, we just, you know, we set out to inform and to generate debate and to talk about technology. I think it was a great event on umbilicals. Going forward, we're going to tackle renewable energy, obviously pre-COP. We'd like to talk about wind, waves, solar, carbon capture, how we clean up the oceans. I think it's very relevant to the Middle East. You know, what we do with our vessels offshore, you know, how they operate and finding ways to reduce their carbon footprint. We want to talk about AC/DC, which I think is really interesting in the context of the Lightning project. There's lots of interesting topics to debate around cable umbilical lay, given what's been going into the water in the last couple of months and years. We want to talk about shallow water completions at some point. That's the stuff that Richard was talking about with IWOCS completions. At some point, I think we'll see shallow water subsea completions in the Middle East, and who knows, we'll see some IWOCS being deployed. We certainly see them in the Egyptian market. Then there's design and repair, and then at some point we're going to talk about seabed survey. Just a quick plug for ADIPEC. It will have its own dedicated offshore marine and logistics zone this year. It will be across the bridge. I know it wasn't included last year, but it's a big plug to anyone in the offshore marine industry. It'd be nice to see McDermott, Saipem and MPCC on the other side of the bridge, where some of the subsea offshore marine players are. But I think it's going to be an amazing event. I'm chairing at least one of the technical papers for SPE. I think there are over 115 submissions for the offshore marine logistics and subsea space, and at least 9 technical sessions. So if you want to join up as a delegate or get involved in the SPE technical session, that's great. Or, of course, from a company perspective, get involved in the marine and logistics zone, and the SUT will have a stand there. So without further ado, final slide, just to thank you to my committee, two ends of the road in Dubai and also Abu Dhabi, for all their hard work. Hopefully you can see all of the major players represented in the community here, and there's nobody, I think of many people who aren't on this slide, who are out there in the Middle East doing stuff in the subsea domain. And if you do need to get to or meet any of these companies, you know, please feel free to drop me a line. When it comes to the questions, Neil, I know there's quite a few we didn't get to. Maybe what I will do is I'll just take a list of those, I'll submit them around the speakers, and we'll try and get them answered and sent to all of the various attendees. But okay, so without further ado, we've taken up an hour and a half of your time. Really appreciative to all of those who've joined. Loads of people from Saipem, McDermott, MPCC, which is great. Some of the NOCs, we've had ADNOC, Aramco on the line. So it sounds like we're doing the right thing, and we look forward to hopefully seeing you on the next event on renewable energy sometime during the summer. Great. Thanks to the speakers, and I'm going to cut the call now. Thank you, Neil.
Thank you, Adrian. Thank you, Neil.